Alrighty, so we got a little test coming up in college algebra, and this video will go over the practice problems that we did in class, just if you want to watch us again to get a double dose of what was covered in these problems. Here we go. The first one, we have an order of operations problem, and we want to start always, of course, with our parentheses or other grouping symbols working inside to out. So I would first focus right here and here. And in this set of parentheses, I see 3 minus 3, and I know that that's equal to 0. And then I got a minus 7, and this 3 minus 2 is equal to 1. So we have taken care of those inner parentheses. So now it looks like we can work in here and inside this set of grouping symbols, the brackets. And I'm just going to copy my 3 and my minus 6 and put a bracket there. Negative 5 times 0, well, that turns into nothing. If you're going to make a mistake, it might be right here. Don't forget this is a minus, so that minus will also come along. And 7 times 1 is 7. Still, we are working inside of here. 0 minus 7 in the bracket is going to be a minus 7. And now we're multiplying here. 6 times negative 7, we're going to have a 3 minus. 6 times negative 7 is minus 42. We are subtracting a negative. That means add the opposite. So it looks like the answer here is 45. Now I'm making this video. I had to write the problems by hand. I forgot to bring home the digital copy. I don't have an answer key with me, so I am flying by the seat of my pants here. And of course, everybody makes a mistake, so I could make one too. I hope I don't, but let's see what happens. Number 2, the directions say evaluate the expression for the given x variable. Well, I got my x is 14. That's going to go in for this x and for this x, and then we're just going to compute and see what our final answer is. So we're going to have 2 times the quantity. X turns into a 14 plus 3. Denominator, we have 4 times x, or 4 times 14, and that's minus 20. All right, I'm going to work over this way. In the parentheses, I have a 14 plus 3, that's 17. I'll put that in for multiplication. And here, 4 times 14, just to be on the safe side, I believe it's 56, but I'm going to do 14 times 4 just to be safe. And I do find the 56, and that is 56 minus 20 in the denominator. Multiply the numerator. 2 times 17 is 34, and 56 minus 20, that looks like 36. Can we reduce? When you have a fraction, it is nice mathematical manners to reduce. When I look at these, I just focus right in on those the ones column, and I see they're both even, so I know they're divisible by 2. Half of 34 would be 17. Half of 36 would be 18. So it looks like 17/18. And let me just double check some stuff here. Yeah, that should be the answer. Number 3, the directions are simplify. So I see we got some brackets. Can we work in the brackets? No, that's an apple and that's an orange. We can't add them. That's an apple, that's an orange. We can't do that either. So it looks like we can do a little distribution here. The 7 is going to go to both of these numbers in the first set of parentheses, and then the 2 will go to both of these. So 7 times 4 is 28, and those are x squareds. Plus 7 times 3 is 21, x, don't forget the variable. Plus 2 times 5 is 10, and those are also x squareds. 2 times x is 2x. So let's combine. It's not simplified until we get all our like terms collected. We have a 28x squared and a 10x squared. Well, that's 38x squareds total. And then a 21 plus 2, and those are x's, that's 23 plus 23x. So we boiled everything down to 2 terms, one of the squared variable and the other of just to the first power. Number 3, we're looking for the union. Now remember union and intersection. Union's easy, it looks like a letter U. Intersection is the upside down equivalent. Remember the intersection is always smaller, that's where the sets overlap and they have common elements between both sets. Here we are looking for the union, so we want to marry these sets, we want to combine them and put them together. So I'm going to start my brackets down here, and I like to do mine in order, least to greatest, and I'm scanning both of these sets. And I see the lowest number in both is 3, so that goes in. The next number would be 8. Now here we have a repeater. We have 2 8s, so do we write 2 8s in the union? No, we're just showing what the combined set is, so we only need 1 8 in there. And then we have 10 is next on the list. We got another repeater, couple of 12s. You know, we just got to write that once. And then we have 14 at the end, and we'll close that set off with a bracket. So there's our union. Again, do not write repeaters in there twice. Here, the directions on your paper say find the distance between the 2 points. If you remember in class, we could do this as the absolute value of a minus b, or the absolute value of b minus a. It does not matter because we're just going to subtract them and then absolute value. So let's just do it both ways. We have our bar, negative 16.7 minus 23.4, and we could absolute that. Or it would also be correct, I'll fix that 3, to reverse that. We could have the 23.4 first, and then that would be minus the negative 16.7. And if I bring up the calculator here, negative 16.7, there's negative, oops, guess we got to clear that. Negative, I guess I need the number first, 16.7, and that's negative, minus 23.4, and that is equal to negative 40.1. And just to show you that it does work either way, we're going to do it the other direction. Clear. There it is. 23.4. And that will be minus a negative, so I'm just going to type that in as plus. 16.7 equals 40.1. And I forgot here, I shouldn't have brought the negative down. Why didn't you stop me? Again, we had the bars up top here. The bars would make that positive, and that's just what the calculator showed here, positive 40.1. Because remember, when we're looking at this as the distance between 2 points, distance is always measured in a positive. Number 6, let me see the directions on the paper for number 6. For 6, 7, and 8 said simplify. All right, so we're just going to multiply and collect like terms. Coefficients, 4 times 10, that's a 40. X to the third, x squared. Remember, when you multiply the like bases, you're adding the exponents. X to the fifth. Y to the sixth times y to the fourth. We keep the same base. We add our exponents and get y to the 10th. So 40, x to the fifth, y to the 10th. Now here we have a division, and if you multiply bases, you add the exponents if the bases are alike. The opposite of multiplication is division, and the opposite of addition is subtraction. So here we will subtract the exponents of like bases. First, 27 divided by 3, that's a 9. And then we have x. 14 minus 3 would be 11, 11th power. And then we have y. 8 minus 5 would be to the third power. Alrighty, easy enough. Here's another simplify one. There are 2 roots we could take on this, I guess. Well, we could distribute the negative 5, oops, get back over there, the negative 5 exponent to the numerator 2 and the denominator y. So if we went this route, we would have a negative 2 to the negative 5th power, y to the negative 5th power. And of course, it's also bad math manners to leave negative exponents in our answer. So we could get rid of these negative exponents by sending them across the division bar. Here is a 2 to the negative 5th. That's going to be sent to the denominator where it will become 2 to the positive 5th. That's a terrible 5. The y to the negative 5th will move up and become y to the positive 5th. Now, an alternate method to do this, whenever I see a negative exponent and a fraction in those parentheses, you could also immediately flip the fraction over. That would be negative y over 2. And we can change that to the 5th power, flip the fraction, change the sign, and now we can distribute the exponent 5 to the numerator y and the denominator 2. I guess we are simplifying 2 to the 5th. 2 to the 5th, I believe that's 32. Let me just double check. Yeah, I think so. So negative y to the 5th over 32. Alrighty, let's see here what's going on with number 9. Number 9, scientific notation. Write the number in decimal. So here I see I have my number, 7.03, and I have a positive exponent. Positive exponent means big number, so I'm going to be adding zeros here to the right-hand side of this. And let's see, how many spots do we have to move our decimal? It's right here now. We're going to move it 5 spaces. So 1, 2, 3, 4, 5. There is our new decimal. And I like to write my big numbers, of course, with commas in the right places. So this is 703,000, and that is negative 703,000. Okay, next one. This is given in decimal. I assume we want to write this in scientific. So our decimal is right here now. We want it to be between the first two numbers. So this number is going to be 1.64. And scientific notation always has times 10 to a power. And that power is the number of decimal moves. 1, 2, 3, 4, 5. And that'll be positive fifth. We moved our decimal to the left. Again, I like to think this is a big number, 164,000. So we will have a high number or a positive number here on our base 10. Here we got to do the operation, and it says round the decimal factor in your scientific notation to 2 decimal places. Okay, so we're going to first take care of our coefficients. 1.2 times 1.3. 1.2 times 1.3. And we get 1.56. 1.56. That is rounded, or that is to 2 decimal places, so we don't have to round like was said in the directions. And we know we're going to have a times base 10. And let's see, we got a 10 to the 13 times a 10 to the negative 11. So multiply bases, add like bases, add the exponents. The difference between there is going to be 2. Okay, 1.56 times 10 squared. And I want to see here, there is your final answer in scientific notation. If we wanted to convert that into decimal notation, we'd move our decimal 2 to the right to make this number bigger. 1, 2, 156. And there we go. Here's a division one. Again, first, take care of your coefficients. 1.2 divided by 3. 1.2 divided by 3, that is a 0.4. And then we have our times 10 to the, and we want to find our new exponent here, subtracting because we are dividing like bases, 6 minus a negative 3. 6 minus a negative 3, of course, we turn those to add the opposite. That'll be a plus, and that will now be 10 to the 9th. So there's our answer. That's in scientific notation, correct? No, it's not. Remember, there'd be a 0 here, an implied 0. Scientific notation, you always have a 1 through 9 to the left of this decimal. So we're not in the right space now. We want to move this decimal over here and make it 4.0 times 10. Now we have to fix our exponent. So we moved our decimal here to the right. Does that make our exponent go up or down? That's going to make our exponent go down. So this 9 is going to drop a value to 8. Be careful if we were already at, say, a negative 9, and we were going to make the number go down, we would drop it down to a negative 10. If we were going to make the number go up to make the number larger, we'd have to move that up to a negative 8. So really be careful when you're dealing on the negative side of the number line there. So now we do have scientific notation. A number, the decimal, and then another number times 10 to a power. Number 13, add or subtract the terms if possible. Hopefully you have these memorized up to 15. The perfect squares, or you will have a TI 30 for the test. The square root of 196 is 14, and the square root of 169 is 13. So we can do those separately, and now that we've had them square rooted separately, we can subtract and get a 1. Remember that answer 1, because if you look at 14, it's very, very similar. Ooh, no, did I mess that up? There should have been, I thought I wrote it in there. No, I'm sorry, I'm confusing that with a later problem. I was thinking of problem 15. So we're going to stop right there on 13. 14, negative 2 to the 4th power. So here we're going to look at just the exponent first. 2 to the 4th power would be 2 times 2 times 2 times 2. Well, this is 4, and you double 4 and you get 8, and you double 8 and you get 16. So that is going to be a 16. Does the negative go along? Well, it's an even power, but we have no grouping symbols. So that negative would just come down. Our answer is negative 16. If, on the other hand, that was negative 2 quantity to the 4th, with the grouping symbols around the negative and the 2, we would have a negative 2 times a negative 2, and that would be positive, and times another negative 2 would make it back to negative, and then another hit would take it back to positive. So this answer would be positive 16. If you're worried about the confusing that, I always just like to think about it, expand it out to that power. Here we have a negative 2 to the fourth. So that is a negative, and then 2 times 2 times 2 times 2. When we stick the negative in the grouping symbols, that's when each of the terms has a negative, and that would come out to be our positive answer. Here's what I was thinking of a couple questions ago. The root of 36 plus 64. Well, since it's grouped under the radical and we have our plus sign, we work under the radical first, and we get the square root of 100 when we add 36 and 64, and the principal square root of 100 is 10. On the other hand, here now we have two separate radicals. Square root of 36 is 6, plus the square root of 64 is 8, and when you add those together, you get 14. Problems that look so similar, it's very easy to come up with vastly different answers. So be careful, take your time and enjoy. Here we want to simplify this, and I'm going to do a quick little list of perfect squares. 2 squared, 3 squared, 4 squared, 5 squared, 6, 7, 8, 9, 10. So we have a number that is not a perfect square, but hidden in it is a perfect square of something. Let's see. 4. No, 4 is not going to go in there. 9 won't. 16. It looks like when we get to here, I always think money, a quarter is 25 cents, $2.50. Yeah, that's a nice round number of quarters there. So 250 is going to be the root of 25 times the root of 10. 250 is 25 times 10. I just broke it into two pieces. Because now this piece is a perfect square, I can square root it to a 5. And I'll have 5 root 10. Sometimes, if you don't choose the right number right off the bat, you might work your way down. Like maybe you get to here and you simplify and you get 5 roots 8. Don't forget, always double check. Even though you simplified it once, maybe you missed a factor, because 8 there would be 4 times 2. And that 4 would come out as a square root as a 2. So even when you simplify it once, make sure you chose the best simplification. It is fully simplified. Make sure you can't break it down any farther with a perfect square. Okay, it looks like we're going to have to do something similar here. Well, in this one, the problem was given to us as a single radical. So we broke it into two radicals. Here we have two radicals, so we're probably going to want to combine them. And we can do that since it's a multiplication, and these are both square roots. A square root times a square root is another square root. 5 times 10 is 50. X times x is x squared. Let me jump back here real quick and grab this. There's my list of perfect squares. 5 had no perfect square in it. 10 had no perfect square in it. So, we had to combine that and get to our 50. And now we see that 50, again, has a nice, and when I think money, 50 cents is 2 quarters. So my nice perfect square 25 is going to go in there. So actually, I can break this up into 3. The first would be the square root of 25. And then what's 50 but 25 times 2? So we got a square root of 2 in there. And we can also put the x under its own, the square root of x squared. So the square root of 25, yeah, that's a 5. The square root of 2, we can't do anything with that. The square root of x squared. Remember, there is an implied 2 here. If you don't see it, square roots are implied 2. The square and the square root cancel, and out pops an x. Do we have to be careful about missing something here because that was an even index? Remember, when you pull out variables out of even indices, technically we'd have absolute value bars around the entire thing, but we do know that positive 5, its absolute value is positive 5, so we can move the bar in and just focus in on that variable. Remember, we have a square root and only positive things come out from under even indexed radicals, so that those bars must be placed around the x just in case the x is a negative number. We have to ensure that it stays positive. Okay, when I look at this one, I see the 150, and that's x cubed. And I see that it has a perfect square hidden in it. That 25 is still in there. But it might be easier if we do a little other work first. I noticed that the problem is given as two radicals in the form of a fraction. They're both square roots, so I can put them under one big radical. And now under the radical, I have my 150x to the third divided by 2x. And now that everything's comfy under the radical, let's divide. 150 divided by 2 is 75. x to the third divided by x to the first is x squared. Okay, we're getting somewhere. We are getting somewhere. 75, again, you know that's divisible by quarters, so I know that's going to be a square root of 25. And what times 25 is 75? Well, that's 3. And then we have our x squared also under its own radical. So the square root of 25, that's a 5. The square root of x squared, again, that'll come out as an x, but don't forget the bars to ensure it's positive. And then we have our radical 3. And let's see what 19 has in store. I got a question mark on there. I can't. The copy I'm looking at didn't come out so great. The directions do say simplify. If it happens to be a, there's my pen. The third root of 8. Well, remember our 8 can be written as 2 cubed. So the cube and the cube root will cancel, and the cube root of 8 is equal to 2. Times we got another cube root of 8. That's equal to 2. So 2 times 2, that's equal to 4. Again, that's what would happen if that is a third root. Again, I can't really tell from my my poor copy from the Xerox. It might be a fifth root. I'm not sure. If that's a fifth root, well, we got a fifth root times a fifth root, so that will be yet another fifth root. And 8 times 8 would be 8 squared, or you could say 8 squared is 64. You know, if that was a fifth root, that's what they were looking for. And there might be one other option. Let's also explore this. I didn't write it up here. But maybe it's a square root of 8 times a square root of 8. If that's the case, you know, a square root times a square root is a square root. And 8 times 8 is 8 squared, or 64. And the square root of that, again, the square and the square root cancel. That would come out as an 8. I hope that the test has better clarity on those little radicals. If not, I'll have them written on the whiteboard. Number 27 is also under the directions to simplify. So I see 27 to the negative 1/3. I focus in on the negative exponent. I, of course, want to address that first. So to get rid of the negative, we move the whole thing to the denominator. Now it's 27, to the 1/3 power. And let's see if we can simplify that. You know, the 1/3 power, you know, we're not real familiar and thinking what that really is saying. So let's put the 27 under a blank radical. We know that the denominator here becomes our index. That's a third root of 27 to the first power. Does 27 have a third root? Well, yes, 27 is 3 to the third. So it's a cube of a cube root. Those will cancel, and we have our answer of 1/3. 21, subtract. I see here we have a cube root of 3, and this is a cube root of 81, so we got an apples and oranges scenario here. Let's do a couple of quick cubes. 3 cubed is 27. 4 cubed is 64. 2 cubed is 8. Well, hopefully one of these three numbers should go nice and even into 81, and our clue is right here. Hopefully, for this problem to work, and these problems are designed to work, we're going to break that 81 up into something times something, and we won't be able to add or subtract in that unless this is a cube root of 3. So what times 81 is, or what times 3 is 81? Well, if you take your calculator and divide each of these into 81, you're going to see that's 27. So 3 cube roots of 27 times the cube root of 3, and then we got this other part of the problem. Don't forget that's a minus 4 cube root 3. We picked 27 because it is a perfect cube. The cube root of 27 is 3, and multiplying by the 3 that's in front, 3 times 3 is 9. 9 cube roots of 3 minus 4 cube roots of 3. So now we have apples and apples. Cube root of 3, cube root of 3, so we can add or subtract the coefficients in front. 9 minus 4 is 5. 5 cube roots 3. Almost done. 22, where's my directions? This still falls under the simplify. The next three all fall under simplify. So I have 4 to the 3/2 power. Well, let's look at that under a radical. Blank radical, 4 is under it. The 2 goes out front for a square root. The 3 stays under as an exponent. So we could do that. Yeah, and this one isn't bad. Let's look at it both ways. If I punch into my calculator 4 to the third, or 4 times 4 times 4, that's 64. And the square root of 64 is 8. The other way to think about it would be, remember this exponent under the radical is a little flexible. We can bring it out. And we could write that as the square root of 4, that quantity cubed. And if we take the square root of 4, the square root of 4 is equal to 2, and we have our parenthesis around that, and that is to the third power. 2 to the third is equal to 8. It worked really well because this was such a low number to a low power, 4 to the third, and we were dealing with square roots. As you get into those higher numbers, it becomes more easy to maybe do it this way. Take that exponent out from under the radical, put it outside some grouping symbols, and then this might be an easier number to work with. All right, we're still looking to simplify here, and we're getting into some fractional exponents, and I see we're dividing. So I would first focus in on the coefficients. 20 divided by 5, that's a 4. We got an x divided by x, so our base is x, and it's common, so we're going to have another base x. Our exponent will be 4 minus 3 halves. That's a 3 halves. To add or subtract fractions, I would like to see my 4. There's a 1 under it now. I'd like to see that to have a common denominator of 2. So if I multiply my denominator by 2, that'll match. I got to multiply my numerator by 2. So the 4 over 1 is the same as 8 halves. And that's going to be minus 3 halves. All right, so that's 4x. And then we got 8 halves minus 3 halves is 5 halves. And I would say since that's the form we were given the problem in, we should probably leave it in that same form. 4x to the 5 halves power. If you went the extra mile and you put it back under a radical, of course, this would be a square root, and the 5 would be in there. 24, the sixth root of x to the third. And it did say simplify, so let's see what we can do. If we write it as a rational exponent, x to a fractional power, numerator, denominator. Ooh, look at that, 3/6. That looks like something that can be reduced. 3/6 is the same as 1/2. And if we wanted to put it back into radical form, that would be just the square root of x. All right, one more to go, and that I believe is rationalizing. Rationalize the denominator. If possible, simplify the rationalized expression by dividing the numerator and denominator by the greatest common factor. And that just means, if there's some coefficients at the front, reduce them. So I see what we got here. Let me give myself a little room to work. I'm going to move this over this way. And first we need to multiply by our conjugate. So our conjugate is going to happen, we're going to multiply that by the numerator and the denominator. And the conjugate has the same terms, a 4 and a root 5. 4 root 5. But the opposite sign. If that's a plus, our conjugate will have a minus. And also the numerator gets the same treatment. Now, I've said in class, my advice is not to distribute the 8. Some of you are going to see the 8 and you're going to want to distribute across the parentheses. Let's not do that right now. And that'll make, if there is any reduction at the end, that'll make that a little simpler to deal with. Okay, so we're going to have 8 times the quantity 4 minus root 5. Denominator, we take the first term times the first term. 4 times 4 is 16. Minus, it's always minus. Root 5 times root 5 is 5. And our numerator will leave, again, that undistributed. Denominator, 16 minus 5, that is 11. If these numbers were a fraction that could be reduced, this would be the point to do it. And again, that's why you would not want to distribute the 8. It would make seeing any reduction here a little harder to pick out. So I hope the little video helped here. Good luck on the test.